Welcome to the Quantum Ireland podcast, your gateway to the fascinating world of quantum computing, science and technology. Our podcast delves into cutting-edge research, groundbreaking discoveries and innovative applications emerging from Ireland's vibrant quantum community. Join us on this journey as we unravel the mysteries of quantum computing and uncover the endless possibilities it holds for the future. Get ready to dive deep into the quantum revolution with the Quantum Ireland podcast. Hello everybody, I'd like you to meet Ian Pepper. Ian Pepper is a quantum computing and AI consultant, and he's recently worked in Novartis. And Ian is going to give us a little bit of an overview about quantum computing, what it is, what it isn't, what's the potential, some of the challenges that we need to overcome, and some of the applications for that. Ian, thank you very much for joining us on the show today.
It's a pleasure, Mark. Thanks for having me.
So, quantum computing, for people who may not know too much about it, would you be able to give us a little bit of an overview about what it is, how it differs from regular computing? And I believe you've got some slides to kind of help navigate us on this journey.
Thanks, Mark. Yeah. Quantum computing is one of those interesting topics that's best described visually. So I've taken the liberty, as you said, of just 3 slides just to give a flavor. And then maybe I can tell you about some of the other applications that we see, and possibly its relevance in the whole world of AI and machine learning. So quantum computing is like a relatively new paradigm it's a new approach to solving problems with a different type of computer, because there are all these problems out there that no one really talks about that haven't yet been solved. For instance, making fertilizer uses a process called nitrogen fixation, and that uses 2% of the world's energy and gives off about 3% of the world's greenhouse gases. And what's interesting about the process is the industrial process is we know that it can be done in nature. There's a bacteria that actually does it at ambient temperature. We just don't know how it does it, because it's impossible with even today's supercomputers to model how that bacteria works. On the screen here of an example of where we think a quantum computer can do something that even the fastest regular computer today can't do. So you can see on the left-hand side, we have what we're calling a classical computer. In other words, today's digital computers. Factoring a very large number into its 2 factors. Say you've got 2 prime numbers, 2 large prime numbers, you multiply them together, and then you want to find out what the factors are with a computer. So as you can see, the best known algorithm today on even the fastest regular computer would take an enormous amount of time. Whereas on the right-hand side, you can see how fast a quantum computer could solve the same problem. And you can see that the quantum computer is much, much slower. It's a megahertz quantum computer compared to a terahertz classical computer. And it's believed that a quantum computer could solve that problem in 8 hours, which is quite remarkable. So the upshot of this is that the left-hand side is actually how most of the world's encryption works today. Things like RSA encryption is based on multiplying 2 large prime numbers together. So we can see that there's a problem as quantum computers begin to emerge. Now, it's not a problem just yet, because although there are working quantum computers out there, they're still very experimental, and they're very sensitive. Most of them use a technique called superconducting, and superconductors require very, very low temperatures, nearly absolute zero. And they have to be isolated, encased in lots of shielding to keep them free from cosmic rays. They're very, very sensitive devices. So we don't need to panic just yet, but the US government and others are working on what's called post-quantum cryptography, which will be a way, new encryption algorithms that would be safe with a quantum computer. So this is one of the things that we see a problem being solved that can't be solved today with a quantum computer. And like I said, other ones are the whole nitrogen fixation problem. Another one is battery technology. I know if you ever wondered why it takes so long for companies to come up with a new type of battery, I mean, I remember, nickel cadmium in the 90s was the state of the art, and now we've got lithium ion batteries. But nothing has moved beyond that, really. It's been very incremental. And the reason why is because we don't really know what goes on between the cathode and the anode. It's theoretical, it's guesswork. So the only way of improving a battery today is to do lots and lots of experiments with different materials. Whereas we believe a quantum computer will be able to unravel actually what happens between the anode and the cathode in a battery.
So Ian, if I stop you there, so for people who are kind of coming in here from different backgrounds, who may not have a kind of a computer science or technical background, and there's a lot of companies who are significantly investing, I think of companies like IBM, for example, who are investing an awful lot in this area. What are some of the challenges to solving these problems? And you gave a great example of if this actually plays out, it could save huge amount of time.
Yeah, there's massive challenges. The adoption of quantum computing is it's huge in the research community and in government community. I mean, the Irish government recently launched their quantum strategy, which I'm a part of implementing. We've got the Irish Centre for High-End Computing, also has a quantum strategy. Trinity College has a master's now in quantum technology. So the background to it is, I guess, to introduce quantum technology at the level it's at the moment, you do need to have the education and training in that area. And there just aren't enough people who know this area very well right now. So there's a lack of quantum practitioners out there. But that's not to say that companies don't see the value in it and are willing to train people. Some are. IBM is a very good example that you mentioned.
And when you look at the potential of training people up, getting it out to the masses, and ultimately kind of jobs are going to be coming from this area as well, is this 3, 5, 10, 20 years away, or how do you see this kind of playing out?
It depends on who you ask, Mark. If you'd asked that question 10 years ago, most physicists would have said it's impossible to build a physical quantum computer. It just couldn't be done. IBM, many others, even Equal One here in Ireland, are building quantum computers, and they're all having some level of success. But I think what will happen, if you think about classical computers, like on the left-hand side here, how many people know exactly how they work internally, how the hardware works? And the thing is that people don't really consider that level anymore. They're more focused on the application level, the higher level software to build applications. No one really worries about how the actual thing works at a basic level. And I think that's what we'll see on the quantum side as well. Right now with quantum computers, it's very low level. You have to build circuits. You've got to know all kinds of strange and wonderful things to get it to do something useful. But there's no reason as it matures that this couldn't be abstracted away and made as easy as using a classical computer. As to how long it will take, the most optimistic is probably 2 years to make the next breakthrough, and some others think that it could be as long as 10 years away. My view is it's somewhere in between, maybe 3 to 5 years before we see something valuable in this space.
Because in this world, ChatGPT has taken the world by storm. We've had in the last 12 months, depending on who you speak to, you've had, mobile, you've had the web, and you've had ChatGPT, and now it's exploding. How do we see quantum and AI intersecting, and what's the potential for that?
There's massive potential, particularly in the area of LLMs, large language models. One of the massive issues with large language models, and working in Novartis, we used predecessors to ChatGPT, things like BERT and BioBERT for adverse event detection. And with those, they're not as big as the GPT-3 model or GPT-4, is that to train the model took days and days and days and weeks, using 10 GPUs in the cloud. And I've heard anecdotally that ChatGPT, the reason why they stopped with the date of the end of 2021, I believe it didn't know anything beyond that, is because of the sheer amount of time it took to train the LLM. You're talking weeks or months and using a vast amount of resources. So you can imagine that it's, clogging up a large portion of a Microsoft data center. It's also using a vast amount of energy to do that. So there is what's called a quantum speedup. We could put a quantum computer in there, and using some very clever algorithms that have been put forward by researchers, it would exponentially speed up the training of these large language models. So that's one of the reasons where we see the intersection of quantum computers and AI or machine learning. Other things that have been proposed with quantum computers, instead of having a dictionary, for example, is that you could have a dictionary of all possible sentences represented in a large quantum computer, which could potentially, open up a whole new avenue of natural language understanding applications, which could be a hugely interesting thing that no one's never really thought of before.
So there's a few different ways that it can even just complement and enhance.
Absolutely.
Because you, as you rightly said, ChatGPT and OpenAI gained 100 million users in seconds, it seemed like, and people are able to use this for different interfaces and engagements. That the case study is now coming to the market. So then, if you can fast track that, and it makes it so available for everybody just to start to use and engage. It's phenomenal to see what's going to happen in the short to medium term. When we look at the work that you did in Novartis, and you had this kind of special role where you had AI and quantum in terms of the research ability that you had and working with the company to try to utilize that. Tell us about some of the work that you've done that you're most proud of.
Yeah, I guess one of the big things we did was we looked at a problem that knowledge workers have in large organizations, and that is finding the information they need to do their jobs effectively. So there's some research done a number of years ago, which suggests, by a company called IDC, suggests that knowledge workers spend 40% of their time looking for the information they need to do their jobs. So we looked into this and we discovered that, yep, we do have a lot of, pockets of highly skilled workers that spend all day searching for information to do with clinical trials, for example, clinical trial results, or regulatory submissions, things like that were very common. So specialized workers spend all their time looking for stuff rather than doing stuff. So we looked to see if we could speed up how they work. So we discovered that the search functionality that they used within the organization was quite poor. It was, just word matching using something called the FAST algorithm, which is integrated with SharePoint. So we looked to supercharge that, and we introduced a system which used semantic search, which is a natural language understanding, natural language processing system to understand the user's intent. And also by bringing in, things like knowledge graphs of the taxonomy of everything in Novartis, in as much as we could, pulling all those things together allowed us to supercharge the search experience for those knowledge workers and give increased productivity and happy workers. So that's one thing I'm very proud of. Is one of the more recent things I did.
And when we think of semantic search, Ian, just for people who may not know what that is that like you've got cats and dogs and you've got different kind of similarities between certain terms
exactly.
and helping to a search? Because if you think about, we're all comfortable using Google search and we're all trying to, and it becomes so easy to use, because as you type, it will actually pre-formulate you options to actually determine what you're going to be able to choose. But for a lot of us, we're actually doing search, as you said, you're trying to find information either on your intranet, you're on your own device, you've got an enterprise system, and it gets messy very, very quickly.
Exactly.
So it's a real time saver to be able to do that, but also just to be able to get access. People want to have that self-serve option. They don't want to be calling call centers or filling out different online forums or engaging with different chatbots to do that. They want to be able to get that information. And as well, I'm guessing you probably would save people hours on that type of work.
Oh, absolutely. Yeah. I mean, we found we also supercharged the enterprise search as well. It was everything was using the same technology. It's older SharePoint stuff. So we were able to supercharge enterprise search as well by making that semantic as well. And just for your listeners or your watchers, so the simplest example of semantic search is, say you have a number of documents, and those documents contain cats, the word cats or species of cats, and another document contains dogs or species of dogs. And you do a search then across those documents for the word animal. There will be no match with a classical kind of algorithm because the word animal or animals doesn't appear in the document, in any of the documents, so that you'll get no results. But in a semantic search environment, if you type in animals, you will get the documents with cats in it and dogs in it, because it knows that a cat is an animal and a dog is an animal as well. So it's a more general query you've given it, and so it's able to serve up the answers better. So using those techniques, we were able to greatly enhance the internal search experience. And some people might be thinking, well, why can't you just give me Google? I mean, that's what we were asked all the time. And the answer is that you can't license Google for internal use. And the second thing is that Google has a massive team of people who curate all of the data. And one of the differences I don't know how many times I explained between an intranet and the internet, if you like, is that the internet, the information and web pages in the internet are made to be discovered. So when you create a web page, you give it stuff to make it easy to find and to make it Google friendly. Whereas internal documents, Word documents or whatever, are just thrown into SharePoint. There's no metadata or anything necessarily associated with them. So they're much harder to find. And that was the challenge that we had, was educating people is that you can't just have Google, and that you need to realize that your intranet is where stuff, it's a repository, not an index of information or knowledge.
And it's a brilliant point, Ian, because it also kind of goes on to my next point, where if you as an organization and a company start to become really good at tagging your data and putting good meta descriptions on that data, you could actually start to use your own language, or get an open source large language model and use your proprietary data to start creating some real insights for internal customers or external customers to use and train it. So for example, you could have frequently asked questions that are, like the question you got asked there, you could actually put a proper answer to that, and you'll be able to have that reference point for people to use. So there's huge opportunities to not reinvent the wheel here, but be able to actually introduce AI internally and externally.
Absolutely. So I think that the next big thing we're going to see in the whole natural language area is the introduction of LLMs into the internet in large corporates. As you can imagine, companies like Novartis are already working with Microsoft on this, as are many others. There's a few challenges to overcome. The training of the model to add the internal knowledge of an organization is still a big problem and a big ask to add that information in. With the previous generation of models like BERT and BioBERT and so on, were still big models, but not nearly as big as GPT. So again, it goes back to that whole, do you want to rent a data center for a month to train and a load of GPUs to train the model? And you're not going to have to do this once, you're going to have to do it periodically as as more data and documents are added internally in the organization.
Yeah, so there's a big decision to make.
Absolutely.
Are you actually going to go and take the research that you're doing yourselves and put it into production, and then have to deal with that once it's in production, manage for drift and updates and all these different things? or buy an off-the-shelf product and service. And we have now, since Friday, since Saturday, the AI Act is now being ratified. So we expect that in the next 2 years or so, regulation, so people will start to feel more comfortable about the AI products and services they're going to start to use, and it's going to drive that across their business.
Sure.
Well, hopefully in the years to come, we'll be talking about a quantum computing regulation, which will be very, very exciting.
Absolutely. And, the intersection of quantum computers and AI, I think, is going to be the next big thing.
So, Ian, for people that want to find out, engage with yourself, or either on AI or quantum computing kind of consulting services, what's the best way to get out to you?
Just to reach out to me on LinkedIn. There are 2 Ian Peppers. One is a professor of soil technology in the University of Arizona, and the other one is me. So LinkedIn is probably better.
Yeah, pretty impressive. But the other person that's also recognized as Mark Kelly is a famous astronaut. So so I'm not the astronaut. You can reach out to me. I just stick in my name.
Excellent.
Ian, thanks very much for your time today.
Thank you, Mark. Pleasure.
Thank you for tuning in to the Quantum Ireland podcast. Stay connected with us for future episodes where we'll continue to explore the mysteries of the quantum realm and keep you updated on the latest developments from Ireland's quantum community. Don't forget to subscribe, rate, and review the podcast to help us reach more curious minds like yours. And if you have any questions, feedback, or topics you'd like us to cover, feel free to reach out. Till next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible with quantum computing.